Welcome, everyone, to the Meteorology Matters podcast. Today, we're embarking on a really crucial discussion, digging deep into an event that has left so many people asking some profound questions. And we're here to try and give you the insights you need to understand it fully. We are focusing on the catastrophic flash flood that struck the Texas Hill Country back on July 5th, 2025. This wasn't just, a severe weather event. It was a truly devastating human tragedy. It claimed an astonishing number of lives, including, very sadly, many children. It just raises these critical questions about our forecasting capabilities, the communication channels that are supposed to keep us safe, and frankly, the state of our preparedness. How could something like this catastrophic, unfold even though warnings were issued? Were those warnings actually sufficient, or was there some kind of fundamental breakdown somewhere else in the chain of public safety? To help us navigate these incredibly complex and often, heartbreaking layers, we have an expert with us today, someone who can really connect the intricate dots and provide some invaluable context for these challenging events. We're going to unpack this recent tragedy, hopefully giving you a much clearer picture of what really transpired. And remember, you can find more in-depth discussions just like this one by searching Rob Jones Hurricane over on YouTube. You'll also find the Meteorology Matters podcast playlist right there. And please be sure to follow meteorologist Rob Jones on Instagram, that's meteorologist, and also on TikTok at TV Meteorologist.
The nightmare unfolds in the Texas Hill Country.
Let's start, if we can, by just confronting the immediate devastating human impact of this truly horrific event. The images, the personal accounts coming out of the Texas Hill Country are just, well, they're gut-wrenching. We're talking about widespread destruction and a profound loss of life. As of the recent reports, at least 37 people are confirmed dead across Texas because of these floods. And maybe the most heartbreaking part of this toll, it includes 14 children. Just trying to imagine the terror, the desperation. Search efforts have been agonizingly slow, really arduous, and they're still ongoing for over 24 children reported missing from Camp Mystic. That's a well-known Christian summer camp right there in Kerr County. The thought of those young lives just so abruptly and tragically cut short, it's almost unbearable. And the sheer scale of the environmental destruction is also almost impossible to really comprehend. The Guadalupe River in Kerrville, typically it's this tranquil waterway just meandering through the landscape. It transformed into just an unimaginable torrent. It rose an astonishing 26 feet.
26 feet?
Yeah, that's a staggering 8 meters in just 45 minutes.
In 45
Before daybreak on that Friday. Think about that for a second.
Yeah.
A literal wall of water moving with incredible speed and just this almost unfathomable ferocity.
Unbelievable power.
Sweeping away everything that stood in its path. It devoured homes, vehicles, the very landscape itself. The scene left behind in the wake of this deluge, it's just a stark, chilling testament to that raw power. Homes and vehicles, once, firmly rooted, they were simply ripped from their foundations, carried violently downstream,
Just gone.
ending up as just mangled debris miles away. Trees, once strong and vibrant, found twisted, splintered along the flooded riverbanks. In some cases, entire structures just reduced to little more than rubble. We've seen images, haven't we, of buildings missing entire front walls.
Yeah, just gutted.
Exposing their interiors. Or that pickup truck tossed onto its side like a toy.
Utterly powerless against that force.
And the personal accounts, the stories from those who lived through it or desperately searching for loved ones, they're truly agonizing. 13-year-old Eleanor Lester, she was a camper at Camp Mystic. She described the site as being completely destroyed. She vividly recounted the chaos, the sound of helicopters landing, carrying people away to safety, and the terrifying experience of girls, including herself, just holding onto a single rope for dear life to cross a whipping bridge
Oh my goodness.
with the raging waters swirling, thrashing around their legs. Then there's the harrowing story of Erin Burgess, who found herself clinging precariously to a tree with her teenage son.
Just holding on.
Watching in horror as her boyfriend and their beloved dog were tragically swept away by the relentless raging currents. And Barry Adelman shared how his family, encompassing generations from his 94-year-old grandmother to his 9-year-old grandson.
The whole family.
They were forced to seek refuge in the attic of their 3-story house, water steadily engulfing the lower floors, rising with just terrifying speed.
Unimaginable.
The human toll, the emotional, the physical trauma, it's truly immense. It will resonate for years to come.
What's immediately striking from those accounts, as heartbreaking as they are, is that undeniable element of surprise. This catastrophic event, it didn't just happen, it unfolded right in the middle of the night.
Right, while people were sleeping.
Exactly. Catching countless residents and campers completely off guard, many asleep, unaware of the danger. And it happened in a region that, tragically, is profoundly, historically susceptible to these kinds of events. The Texas Hill Country, as many folks there know all too well, is often and aptly called Flash Flood Alley.
I've heard that term many times.
And it's not just a catchy nickname. It's a stark geological and hydrological reality defines the region. The terrain there is characterized by these rugged, steep hills and relatively narrow river basins and canyons.
Okay.
So what that means is when you get significant rainfall, instead of soaking slowly and harmlessly into the ground, especially parched ground, the water rushes rapidly down those inclines. It funnels and concentrates with incredible speed into those constricted riverbeds. This natural setup creates the perfect conditions for extremely fast-rising, violent floodwaters, often with very little warning for those in their path. The challenges facing search and rescue efforts after something like this are just immense, bordering on insurmountable in some spots. Rescue crews, both local and federal, they're deploying every single tool, every resource they have.
Helicopters, boats.
High-tech helicopters surveying, specialized boats navigating really treacherous currents, drones giving those invaluable aerial views, all operating under extremely harsh, often dangerous conditions.
Right.
We've heard reports around 850 people rescued so far, which is just a powerful testament to the heroic, tireless efforts of these teams.
Absolutely.
But the ongoing search for victims, for those still missing, it's made exponentially harder by several factors. It happened over a major holiday weekend, the 4th of July weekend.
Ah, right. Lots of visitors.
Exactly. Many people traveling, visiting, vacationing. It makes it incredibly hard to estimate precisely how many individuals might be missing or where they might have been. Then you've got the sheer volume of debris, the altered landscape, the continued high water levels.
Yeah.
It all impedes recovery.
It must be incredibly difficult work.
Governor Greg Abbott has publicly pledged authorities will be relentless in their pursuit, vowing to find every one of them. And Homeland Security Secretary Kristi Noem also promised significant federal resources from the current administration to aid in these vital efforts. It's an undertaking of truly massive scale, and the human toll, both lives lost and lives just irrevocably altered, it's profound, deeply tragic.
The forecast. A nuanced perspective.
So given that scale of devastation we've just talked about, and that undeniable element of surprise for so many people, the crucial question that pops up almost immediately is this. What did meteorologists know? And importantly, when did they know it? This isn't just about, raw weather data. It's fundamentally about the flow of critical information, from the science side to those who can actually act on it. What did the forecasts really say in the hours leading up to this catastrophe? And here's where the story gets some important nuance, I think. Initial reports, analysis, they confirmed that both private forecasting companies, like AccuWeather and the National Weather Service, did send out warnings about the potential for flash flooding many hours before the devastating torrent really hit.
Right. That's a key point. It wasn't a complete surprise in the meteorological sense.
So we're not talking about a total absence of warning here, which is a critical distinction, right?
Absolutely.
For instance, the National Weather Service, specifically the San Angelo office, they cover Kerr County. They issued a series of flash flood warnings in the early hours of Friday morning. And then, as the meteorological situation clearly escalated, got more intense, they followed up with something pretty rare and highly significant. Flash flood emergencies.
That's the highest level of warning.
Right. That designation isn't used lightly at all. It's a particularly strong, urgent alert. It signifies an imminent, life-threatening situation. A clear, unequivocal signal that extreme danger was unfolding right then.
You've really hit on a vital point there about nuance. Well, the devastation that unfolded was, yes, unprecedented in its immediate impact and scale. The forecast, in terms of identifying the potential for a truly significant event, was actually, relatively speaking, quite good.
Okay, so not a total miss then.
Not a total miss, no. And that's a crucial takeaway. Forecasters had, for days, identified the risk for what they internally called a lower probability but much higher impact flood event overnight. Lower probability, higher impact. That specific phrasing tells you they were aware of a lurking severe threat. Even if the odds were uncertain, the potential consequences were clear in their minds. Let's really dig into the specifics, though. What was predicted versus what actually happened? Because the numbers, they paint a stark picture, but they also highlight the forecasting challenge. Earlier in the week, initial NWS forecasts for the hill country predicted widespread rain totals, maybe 4 to 8 inches.
Okay, 4 to 8 inches.
Then a flood watch was issued through early Friday morning. It cautioned for more general widespread rain, 1 to 2 inches, but critically, it also highlighted a narrow band where 3 to 5 inches were possible, and it warned that this would likely lead to flooding.
So potential for 3 to 5 inches and likely flooding.
Right. Now, contrast those predictions with the brutal reality. The hardest hit area around Kerr County received widespread totals of 10 to 15 inches of rain.
10 to 15?
And in some highly localized spots, that number soared, exceeding an astonishing 18 inches.
18 inches.
Think about this. In some places, 4 months' worth of rainfall came down in just 4 hours.
4 months in 4 hours. That's almost impossible to imagine.
It's an almost unfathomable amount of water in such compressed time, and it far exceeded even the higher end of those initial predictions. So, while the exact extreme intensity and the precise, localized bullseye of this unprecedented deluge were incredibly difficult to pinpoint with absolute certainty days in advance, and that's a common challenge in meteorology, pinpointing the exact location of the heaviest rain.
Sure.
Forecasters were absolutely diligently watching for specific atmospheric conditions that could lead to such catastrophic deluges. They were, for example, keenly observing for training storms. You mentioned that earlier.
Right, like cars on a train track.
Exactly, where individual thunderstorms repeatedly regenerate and pass over the exact same area, each dropping a fresh load of rain. They were also meticulously tracking a mesoscale convective vortex, often just called an MCV.
MCV, okay.
This is a weak, swirling, low-pressure system in the atmosphere, maybe 20 or 30 miles across, but it can act like a pinwheel, circulating vast amounts of tropical moisture and effectively pumping it into an area.
So it concentrates the moisture.
Precisely. These are the kinds of systems that, if they stall over one region, can dump immense, sustained amounts of rain. Forecasters at the San Angelo Weather Service office, for instance, they even specifically wrote in their internal discussions on Thursday afternoon about the potential for torrential rainfall and flash flooding if a weak system converged with the extremely moist air mass already in place. They acknowledge the uncertainty, though, stating, and this is a direct quote, "Still, these features are so weak and the interaction so complicated, if and where this band develops remains uncertain." But despite that uncertainty, the concern for a very severe event was undeniably there in their internal discussion.
Right, they saw the ingredients were present.
They did. And as the early morning hours of Friday progressed, the picture rapidly became much clearer and far more dire. By 4 a.m., it was absolutely evident that the rainfall was far, far more intense and widespread than even the escalated initial projections. This critical real-time understanding led to a stark and unequivocal Facebook post at 4:26 a.m. from the San Angelo meteorologists, a desperate, urgent public warning.
What did it say?
It said, in bold, "This is a life-threatening situation. 6 to 10 inches of rain has fallen, and an additional 3 to 4 inches is expected through daybreak."
Wow, very direct.
Extremely direct. This was a clear, urgent warning issued as the most dangerous phase of the event was actively unfolding. So if we analyze the forecasters' actions purely in terms of their meteorological responsibilities, they did precisely what they were supposed to do within the limits of scientific prediction. They identified the initial risk, diligently tracked the system as it developed, and, crucially, escalated their warnings in real time as the unprecedented magnitude of the rainfall became terrifyingly evident.
So the forecast, while obviously not predicting 18 inches in one spot days out,
Right. That's incredibly difficult.
it was relatively good in flagging the danger and escalating warnings, especially considering, as we'll discuss, the pressures the NWS is under.
The science of the deluge. Why so much water?
Okay, that brings us right to the heart of the meteorological forces at play here. We've discussed the devastating impact, the fact that warnings were issued. But to really understand the sheer force unleashed that morning, we need to delve into the atmosphere itself. What were the extraordinary atmospheric ingredients that lined up to create this catastrophic downpour? This wasn't just a normal thunderstorm, clearly.
Oh, absolutely not. This was a convergence of multiple powerful factors, an almost perfect atmospheric alignment that created truly extraordinary conditions. A set of meteorologists would describe as exceptionally rare. First and foremost, the sources of moisture fueling this event were just incredibly abundant and intensely potent. You had these powerful, deep plumes of moisture streaming continuously northward, directly from the warm waters of the Gulf of Mexico, like an open spigot, really.
It's pumping it in.
Exactly. But there was another equally critical element adding to this saturation, the lingering remnants of Tropical Storm Barry.
Very. was days earlier, wasn't it? Over Mexico.
It was. The system had officially dissipated over northeastern Mexico about 5 days prior, but it left behind this intensely moist, highly unstable air mass. This residual moisture slowly wafted northward right into Texas, effectively preloading the atmosphere over the region, like a giant invisible sponge already saturated to its absolute limit before the main event even started. And to compound this already precarious situation, sea surface temperatures in the Gulf of Mexico had been running significantly above average for months leading up to this.
Warmer water means more evaporation, right?
Precisely, which translates directly into more water vapor being infused into the atmosphere, essentially more fuel for any potential storms. And as if that wasn't enough, even more moisture was pulled in from the Pacific Ocean to the west, adding yet another layer to this atmospheric cocktail.
So moisture from the Gulf, remnants of Berry, and the Pacific.
Yes. All of these factors combined to create an atmosphere so primed for massive rainfall that it was frankly astonishing. Then you had the actual mechanics, the training storms, and that mesoscale convective vortex, MCV, we mentioned. This weak swirl, only about 20 to 30 miles across, it didn't just circulate tropical moisture, it acted like that pinwheel or conveyor belt. Instead of moving quickly and allowing storms to pass, it stalled, almost completely.
Just sat there.
Pretty much, causing storms to repeatedly regenerate over the exact same area, continuously wringing out moisture again and again, over and over. As one meteorologist vividly put it, it was a weather system without a road to get away from the Lone Star State.
Why didn't it move?
Because the crucial upper-level winds, the powerful steering currents of the jet stream, they just weren't present in that area to push this moisture-laden system away. It was essentially stuck in place, relentlessly dumping rain. The sheer, almost unimaginable amount of moisture contained within that column of atmosphere was staggering. Total atmospheric moisture readings in this region were recorded in the top 0.5% of historical observations for this time of year, the top 0.5%.
Top 0.5%? That's incredible.
It is. To try and grasp that scale, consider this. If you could condense all the water vapor above just a single square inch of ground, it would have amounted to 2.25 inches of liquid water.
2.25 inches of water just held in the air above every square inch.
Exactly. That is an extraordinary amount of potential rainfall, far exceeding what's typical, truly priming the atmosphere for a deluge of historic proportions. Imagine that massive sponge constantly being squeezed out over the same tiny spot, then immediately dipped back into an overflowing bucket of water, only to be squeezed out again, each squeeze delivering more catastrophic rain. Now, overlay all of these extraordinary atmospheric conditions with the unique local geography of the Texas Hill Country.
Back to Flash Flood Alley.
Back to Flash Flood Alley, exactly. Known for it for a very serious reason. The rugged hills, carved by ancient rivers, the narrow, winding river basins. It means when water falls, it doesn't soak in well. It rushes down quickly, accelerating and concentrating as it flows into the valleys. And to make matters even worse, the area had been experiencing significant drought conditions in the months prior.
So the ground was hard.
Dry, parched, hard ground acts like concrete, as one senior meteorologist described it. It has very little capacity to absorb water. So virtually all of that immense rainfall immediately becomes rapid runoff, dramatically intensifying the flood potential. And it's vital, I think, to connect this event to the broader context of our changing climate.
The climate change link.
Yes. Meteorologists and climate scientists consistently explain that a warmer atmosphere influenced by human-caused climate change can indeed hold significantly more moisture, more water vapor.
Okay.
This doesn't necessarily mean we'll see more rain events everywhere all the time, but when they do occur, they have the potential to be far more severe, more intense, more concentrated in localized areas. They can tap into what Shel Winkley of Climate Central aptly termed a historic level of moisture. Brett Anderson of AccuWeather echoed this, noting a warmer atmosphere holds more moisture, and we're observing much more total atmospheric moisture globally in recent years.
So more fuel available when these events happen.
Yeah, exactly. So while this was roughly a once-in-a-generation event in terms of its intensity, it unfortunately fits a pattern consistent with climate change projections. A former chief scientist for NOAA, the National Oceanic and Atmospheric Administration, Ryan Mao, he calculated, get this, an astonishing 120 billion gallons of water.
Billion. With a B.
120 billion gallons dropped on Kerr County alone in just a few hours.
That number is just staggering. It speaks volumes.
It really does.
The communication chasm, Warnings versus preparedness.
Okay, so we've established the atmosphere was primed, almost unprecedentedly so, and that meteorologists did see the significant risk and issued warnings, escalating them as needed, even if the absolute peak rainfall was hard to nail down beforehand. But here's where it gets really, well, perplexing and critical. If those warnings were sent, then why? Why were so many people, especially those children at the summer camps, caught so utterly by surprise in the middle of the night? This raises incredibly uncomfortable questions about preparedness, doesn't it?
It absolutely does.
Why weren't these camps evacuated in advance, especially given the known risk in Flash Flood Alley and the warnings about a potentially high-impact event overnight? Was there just a profound breakdown in communication somewhere in that chain between the forecasters and the local officials responsible for safety?
This is, without a doubt, the absolute crux of the problem. The critical communication chasm that appears to have tragically unfolded. What we're seeing are significant discrepancies, and in some cases you could argue outright failures, in how these urgent warnings were not just received, but also interpreted and ultimately acted upon. AccuWeather, for instance, the private forecasting service, they stated unequivocally in their post-event analysis that their warnings should have provided officials with ample time to evacuate camps such as Camp Mystic and get people to safety.
That's a pretty direct statement. Ample time.
It's very direct. It challenges any claims of a complete lack of foresight or sufficient warning time. Yet we have these conflicting statements from various officials, which creates a really confusing narrative for the public, trying to understand what happened. Nimkid, he's the chief of the Texas Division of Emergency Management, TDM. He publicly claimed that original forecast did not predict the amount of rain that we saw.
Which seems to contradict what the NWS and AccuWeather are saying about identifying the potential for a severe event.
It does seem to contradict that nuance. While the exact totals exceeded initial lower-end predictions, the severe potential for a high-impact flood event was clearly identified, and crucially, those flash flood emergencies, the highest alert, were issued as the event intensified overnight. Chief Kidd also mentioned that his agency, TDM, worked with our own meteorologists to fine-tune that weather statement. But he conspicuously didn't elaborate on any updated, urgent interpretation that should have, or could have, led to earlier, proactive evacuations, especially of vulnerable populations like those camps.
So they fine-tuned it, but didn't necessarily issue evacuation orders based on that.
That part remains unclear from his statements. Furthermore, Lieutenant Governor Dan Patrick stated publicly that a senior TDM official, Region 6 Assistant Chief Jay Hall, personally contacted the judges and mayors in that area and notified them all of potential flooding. Patrick added, "Yesterday morning, the message was sent. It is up to the local counties and mayors under the law to evacuate if they feel a need. That information was passed along."
Okay, so the state is saying, we told the local guys it was their call.
That appears to be the message from the state level. The responsibility was pushed down to local authorities to interpret and act. But then, you turn to those local officials on the ground, and the narrative shifts dramatically. It paints a very different picture. Kerr County Judge Rob Kelly, he's the county's chief elected official, the primary emergency manager. He directly contradicted the idea of sufficient warning.
What did he say?
He emphatically stated, "We do not have a warning system," and then claimed, "No one knew this kind of flood was coming." He reiterated, "We had no reason to believe this was going to be anything like what has happened here. None whatsoever."
Wow, no warning system, and no one knew. That's starkly different from the state saying they notified them.
It suggests a profound disconnect, doesn't it?
ASAP.
Either in communication or in understanding the severity of the information received. Kerrville City Manager Dalton Rice echoed this apparent lack of awareness, stating simply that the rain event dumped more rain than what was forecasted. These statements from local officials suggest either the warnings didn't reach them clearly, the severity wasn't properly conveyed or understood, or they simply weren't perceived as urgent enough to warrant a preemptive, middle-of-the-night evacuation. And the timing of the public alerts, that's incredibly telling. It points to a critical failure in the dissemination chain. The National Weather Service issued that flash flood warning for Kerr County at 1:14 a.m. Friday, a clear, unambiguous alert.
1:14 a.m.
However, it was at least 4 hours later, a crucial, dangerous delay before any county or city government entity in the affected area posted any directions to evacuate or take shelter on their official social media channels.
4 hours in the middle of the night.
4 hours. This gap is absolutely critical. People are most vulnerable during overnight hours. They're asleep, they're generally not monitoring weather alerts, news, or social media constantly.
Of course.
This significant lag suggests a profound communication problem, not just in the initial issuance of the warning by the NWS, but in its effective and timely dissemination to the public, and perhaps more importantly, in its interpretation and activation by local emergency management and other officials responsible for triggering public action like evacuations. The tragic consequence of this communication breakdown is painfully clear. It was felt directly by those in harm's way. Campers like 13-year-old Eleanor Lester were indeed woken just after midnight by the raging waters and had to be rescued amidst the chaos.
Right when the NWS was issuing its most urgent alerts.
Precisely. That timing aligns perfectly. This sequence warnings issued by meteorologists, but people still caught unaware in the dead of night, strongly highlights the unpreparedness. Not just of the camp, perhaps, but the broader local communication and response system.
Yeah.
It really shifts the focus, doesn't it? From the content of the forecast itself, which again was relatively good in flagging the danger,
Right.
to its effective dissemination, its interpretation, and the critical lack of preparedness or action that left so many vulnerable during those crucial overnight hours.
It raises those difficult questions. Were there clear, established protocols for what a flash flood emergency warning means locally, especially overnight? Were camp staff adequately trained or informed about these specific risks in Flash Flood Alley?
That communication and preparedness gap seems to be what truly exacerbated the tragedy here.
The system under strain, the impact of resource cuts.
So what does this all ultimately mean then? I mean, beyond the immediate events, the tragic communication failures we've just dissected, the individual harrowing stories, there's this much bigger underlying story here, isn't there? About the resources that are dedicated to keeping us safe as a nation. When we look at this situation, there are these concerning systemic issues that just, well, they have to be addressed. This doesn't feel like just an isolated incident. It feels like a symptom of broader pressures on our public safety infrastructure.
You've precisely identified the underlying issue, I think. The criticism, particularly that, frankly, misplaced blame from the Texas Division of Emergency Management chief aimed at the National Weather Service. It comes amid a deeply disturbing backdrop. That backdrop is significant, sustained funding cuts, and chronic staff shortages that are plaguing the National Weather Service and other vital emergency management agencies across the country.
This isn't new, is it?
No, unfortunately not. This situation appears to be an unintended, yet potentially devastating consequence of broader federal policies, particularly those enacted by the Trump administration, which prioritized federal workforce reductions. Let's dig into the specifics here because it matters. The Trump administration made cuts to the federal workforce an early and significant priority. These reductions extended significantly, and some would argue disproportionately, to the National Weather Service. This crucial agency was specifically targeted by something called the Department of Government Efficiency, leading directly to the loss of approximately 600 staffers nationwide.
100 people. That's a lot for a specialized agency like NWS.
It's a huge number. Internal documents and reports, even before the specific flood, indicated the NWS was already preparing for degraded forecasting services and facing severe shortages of highly trained meteorologists. This means less capacity, potentially slower response times, and definitely an increased burden on the remaining staff. And there's a glaring, particularly impactful example of this directly at the local level where this tragedy occurred. It involves a critical position, the Warning Coordination Meteorologist. The WCM.
The WCM, what exactly do they do?
This role is absolutely vital within an NWS office. The WCM is the primary liaison. They coordinate warnings directly with outside entities, local emergency management, law enforcement, the media. They act as a crucial voice, translating complex meteorological information into actionable public safety messages. They build relationships.
Okay, so the key communication link is sometimes.
Exactly. And this specific WCM position at the local NWS office in San Angelo, the one covering Kerr County, has been vacant since April.
Vacant since April, before this major flood.
Yes. The longtime employee who held that role, Paul Ura, someone with tremendous experience, invaluable, nuanced understanding of local weather patterns, local needs, built relationships over years, he took an early retirement package. This wasn't just a random departure. It was part of a structured early retirement program offered during extensive budget and personnel reductions within NOAA, the National Oceanic and Atmospheric Administration, NWS's parent agency.
So forced out by budget cuts, essentially.
Effectively, yes, through these early retirement incentives driven by budget constraints. When you lose someone with that level of institutional knowledge and local expertise, especially in that critical coordination role, it creates a void. A void that's incredibly difficult to fill, particularly in a high-stakes, rapidly evolving situation like a flash flood. And it's not just that one critical role. That San Angelo office, responsible for warnings in this region, currently has 5 other critical vacancies.
5 more.
Yes. Another management position, 2 frontline meteorologists, the people actually making the forecasts and warnings, a hydrologist who specializes in water flow and flood prediction, and an electronic technician who maintains the vital radar and other equipment.
That sounds like a skeleton crew almost.
It creates immense strain. All 5 living former directors of the National Weather Service were so alarmed by these cuts nationally that they issued a stark, unprecedented warning back in May. They feared these reductions would leave the nation's official weather forecasting entity at a significant deficit, just as we head into the busiest time for severe storm predictions like tornadoes and hurricanes.
And what was their biggest fear?
Their absolute worst nightmare, they explicitly wrote, was needless loss of life. A fear that, tragically, seems to have been realized here. Broadly, NBC News reported that the agency was forced to shuffle existing employees around just to cover about 150 vacated positions nationwide, a result of both firings of probationary employees and those early retirements of other experienced workers. This internal shuffling meant some crucial forecasting offices were left without overnight service.
No overnight service for weather forecasting.
In some offices, yes, directly increasing the risk to the public during critical nighttime events like this one. Now, thankfully, the NWS was granted a waiver for a hiring freeze in June and is now actively trying to hire 126 people to stabilize the agency.
That's something, at least.
It is, but the severe shortages and the profound loss of invaluable expertise from those early retirements, like Paul Ura's, mean the agency's capacity is still diminished. This is a deficit that needs urgent, sustained attention and resources. So, when the Texas Division of Emergency Management Chief, NIMKID, wrongly placed blame on the National Weather Service in this specific case, it unfortunately obscures this much larger systemic reality.
Right. It ignores the context of the strain they were under.
Exactly. In this instance, the forecasters, despite operating within a system clearly under severe stress, facing significant understaffing, loss of crucial knowledge, degradation of things like weather balloon launches, which provide vital atmospheric data, they did what they were supposed to do meteorologically. They identified the risk, they issued escalating warnings. The fundamental problem, as we've highlighted, seems to be that profound communication breakdown and the resulting lack of preparedness or action at the local level.
A problem likely exacerbated by the weakened state of the NWS itself.
Undoubtedly. The ongoing defunding of science and crucial agencies by the Trump administration, and, frankly, what they continue to do by defunding, it is going to cause even more problems. It will put more people in harm's way across many vital sectors. Even the Secretary of Homeland Security herself acknowledged this, speaking about the pressing need for upgraded technology, a need that budget cuts directly undermine.
It's a stark reminder, isn't it? The very real human cost when critical public services are systematically weakened.
It truly is.
Lessons from Flash Flood Alley, looking ahead.
It's a really sobering thought, deeply concerning when you connect those dots. And the Texas Hill Country, as you've said, has endured this type of tragedy before. This isn't its first catastrophic flood, and sadly, it probably won't be its last. So, what can history teach us here about preparing for these events? And what does this particular disaster mean for the future, not just in Flash Flood Alley, but potentially across other vulnerable regions? How do we possibly break this awful cycle?
History, in this case, offers a stark, painful, and unfortunately recurring lesson. As we've emphasized that infamous nickname, Flash Flood Alley, it's not casual. It is earned through repeated tragic experience. It signifies an area intrinsically, geographically, hydrologically at extremely high risk for these types of catastrophic rapid onset floods. This recent tragedy, while devastating and shocking, is unfortunately not unique in the long, sorrowful history of this region's weather. It fits a pattern that underscores these systemic vulnerabilities. We can look back at past tragedies to really understand this recurring pattern and the lessons that perhaps haven't been fully learned or implemented properly. 1987, a flood on the Guadalupe River site rise 29 feet, almost identical surge to what we just saw.
29 feet. Wow.
In that event, a church camp bus evacuating children was tragically swept away. 10 children lost their lives.
Oh no, the echoes of Camp Mystic. Chillingly familiar. Then, 1998. Another widespread catastrophic flood event. Near San Marcos got 30 inches of rain in a short period. Homes along the Guadalupe washed off their foundations, just gone.
30 inches.
Demonstrating the sheer force. And more recently, 2015, the Blanco River. Catastrophic flooding during the Memorial Day weekend Houses, bridges washed away, 13 people killed across the region. We've also seen similar deadly flash floods elsewhere in Texas, like San Antonio in June, and in places like West Virginia. It shows this is a dangerous pattern, not just confined to one spot.
These aren't just historical footnotes, then they're grim warnings. Repeated warnings.
Grim, repeated warnings. Exactly. The overwhelming takeaway from this event, underscored so powerfully by that historical context, is the critical, absolute necessity for a robust, consistently well-funded National Weather Service. It's not just about the raw data from satellites and radars. It's about the irreplaceable human expertise to meticulously interpret that data, the dedicated staff to monitor it 24/7, even through the night, and the reliable systems to disseminate those warnings effectively and urgently. And equally important, maybe even more so, are seamless, ironclad communication protocols. Protocols that ensure these critical warnings travel unimpeded and are acted upon. From forecasting agencies directly to local emergency management, to local officials, and most crucially, directly to the public, in a timely, understandable, actionable manner.
And those profound gaps in that vital communication chain were just tragically exposed here.
Exposed in the most devastating way possible. This tragedy, it raises an incredibly important question for all of us, really. Something for you, the listener, to really think about, perhaps explore further. When our natural world becomes demonstrably more unpredictable, when extreme weather events become more frequent, more intense, potentially fueled by climate change, and when our fundamental warning systems are placed under immense pressure, weakened by chronic underfunding, staff shortages, what exactly is our role as individuals?
What can we do?
What is our responsibility in understanding these complex risks and preparing our own households, our communities, and in advocating vigorously for the resources that are absolutely essential to keep our communities safe? And maybe even more profoundly, how do we ensure that those in positions of power, from local county judges to state leaders, federal leaders, consistently prioritize the well-being, the safety of their citizens by investing robustly in critical public services like the NWS, rather than consistently defunding and eroding them?
That's a powerful question to leave us with.
It's a question that demands our collective attention, our critical thinking, and indeed our collective action, if we want to prevent such tragedies from happening again and again.
This exploration into the Texas Hill Country floods. It has been profoundly eye-opening and honestly, at times, deeply unsettling. We've delved into the incredible, almost unimaginable intensity of that rain, the complex and powerful science behind it, and the relative quality of the forecast, despite those inherent challenges and systemic pressures. But what truly stands out, what's been tragically illuminated, is that critical breakdown in communication and the resulting lack of preparedness that so tragically exacerbated the situation. This, alongside that worrying, ongoing trend of underfunding vital public safety agencies like the National Weather Service, it just paints a really stark picture. Thank you so much for joining us on this in-depth exploration today. We truly hope this discussion has provided you with a clearer, maybe more nuanced understanding of what was a complex and truly heartbreaking situation. And perhaps it sparked some new questions for you to explore further on your own. Remember, for more in-depth discussions like this, you can always find the Meteorology Matters podcast over on YouTube. Just search Rob Jones Hurricane. While you're there, you'll also find that dedicated playlist specifically for the Meteorology Matters podcast. And for more updates and insights, please do follow meteorologist Rob Jones on Instagram. His handle is meteorologist, and also on TikTok at TV Meteorologist. Until next time, please stay safe, stay informed, and always remain curious.